This is Jay with Sojourn Cyclery. I'll be taking a more high-tech approach to frame design in this video. I'll be using SolidWorks, which is a 3D CAD system. This is where I left off in the video on drawing the frame. I've opened up the screen now so you can see all the menus for SolidWorks, and if you're using other CAD packages, I'm sure you'll have similar buttons. I will make a few modifications to this drawing. Namely, I'm going to take off this little tail that I would use to join the seat stays. I'm going to do a different approach on this frame, and I'm also going to put in the exact drop that I'm going to be using for this frame, which is a rocker drop. This is what it looks like with those changes. Now I should be able to extrude this drawing into a 3D model. Under the Features tab, I'm going to choose Extrude, and I need to tell it which area that I want to extrude, which is right here. And the thickness, how deep it's going to go, depends on really the head tube diameter. The head tube diameter is 36 millimeters, and then there's 6 millimeters on each side of the head tube. So that gives me a total of 48, but I'm only doing half of the frame, so I really want to extrude this 24 millimeters, like so. The next step will be to cut the channels for the steel sleeves. There are a number of ways this could be done. I could do an extrude cut from these planes up here, or I can do a couple revolve cuts off of the front plane, and that's the way I think I'll do it. Choose that as my normal plane and my sketch plane. Start off with a center line right through the center of the part, and then I just need a regular line parallel to that one. And dimension that. So I actually want to add a little bit. This tube is going to be 28 millimeters, but I'm going to make it 29 millimeters instead to give me a half millimeter per side for some epoxy room. Okay, so that's the first cut. I'll do the front one the same way. This is the sketch for my front revolve cut. It's 36 millimeters the tube diameter. Again, I've left an extra millimeter for epoxy room, and I just simply need to pull the trigger on this revolve cut. It's asking me if I want to enclose it. Yes, I do, and say OK. So those are the two channels for the steel inserts. My head tube insert is 36 millimeters and my seat tube insert is 28, so notice the wall thickness varies. I want to make that consistent. The way I'm going to do that is create a plane and then actually create another plane that is offset by 6 millimeters because that's my wall thickness. And let's see, I want it to flip to the other side. Now I'm going to use that plane to make a sketch that will just cut away everything on the right side of that plane. Feature, cut, make it go through all. This is the end result. You can see now I have consistent wall thickness front and back, and the whole blank has a little bit of a taper to it. I'm now going to round all these edges using the variable fillet feature, which I find to be a pretty tricky thing to use in SolidWorks. I'll attempt the feature, but more than likely I'll have to bail out here and do it off screen because it's pretty tedious. Notice it selected that whole chain, but then you still have to go around and select the yellow lines to make them editable, if that's a word. Double click on that and I can get even more of these points. Let me assign this one 15 millimeters, see what that does. Okay, doesn't show much. Anyway, before I thoroughly embarrass myself, I'm going to go ahead and go offline and finish this task off screen. Well, rather than completely cop out, I thought I would take a little time to show you some tricks. Every time I do this, I learn some things and I forget some things, but let me show you some of the tricks that may make this easier. First of all, I kind of lightened up. I put a wood material in so we can see what we're doing here. That helps a lot. So I've got the variable fillet features selected. I'm going to go around and pick my lines. And again, I got to pick, even though they look like they're selected, they're really not. And let's see, is there a little something in there? Yeah, it sure is. I think it helps to do this continuously, so what I just did by backtracking there may have messed me up, but we'll see what happens here. And by clicking on the line again, you can get some more points to tweak. So I will usually start with something that would be the lowest value. So let me pick on this one and assign it 1.4, and then come down and say set unassigned. And now I should have a continuous fillet at 1.4, and my goal is to get these lines so that they're close but not touching, which gives me a pretty nice rounded edge. And now that I've got this in place, I can go around and start tweaking things a little bit. So that would just be a double click if you want, or right click and then edit feature. And for instance, this one I could bump up. I'm pretty sure it could bump up to 2 centimeters. And I'm going to try it before I go any further. Yep, that worked. And again, edit feature. If that worked, then this down here should handle 2 as well. Again, I'm just trying them one at a time, and I'm getting somewhere. I like this. This is consistent. I could probably bump up the fillet. Well, I don't know. Let me see. It doesn't look bad. The other thing I'm looking for is kind of a constant line that goes through here. Yeah, that's really not too awful bad. But those are a few of the tricks that I use. Start with a small fillet and bump them up one at a time and check it each time. So I am going to go ahead and sign off here and finish this off screen. So this is what I ended up with a lot of trial and error. And it looks okay. This line is a little goofy here, but when I turn these lines off, you can see it looks nice and smooth. My wall thickness on the top is pretty even on all of these. Overall, I'm really happy with this. The next step will be to cut a relief in here for the chainstay, so there'll be like a little edge that will help support that chainstay. This edge, which it looks like is almost 2 centimeters, I want to have a plane in here about 5 millimeters from that face. But keep in mind this face is not parallel, so I'm going to actually offset a plane off of here. Do my reference geometry plane, and I want that to be 2 centimeters minus 5, so that's 1.5. And let's see what that looks like if I'm on the right side. Let's flip it to the other side. Looks good. I'm now going to use that plane as my sketch plane. Let's make it normal too. I'm simply going to convert these edges into lines. and then trimmed corner will work from here to here. Now that I have that sketch on that plane, I will go ahead and create my extrude cut, and I want that to go through all. So you can see I've created that shoulder that I'll use to help support the chainstay. Next, I'll turn my attention to the inside of the frame. I've already created these cavities to support the steel tubing. Now I'm going to create some cavities here to hollow the frame. Now this is optional. When I'm finished here, I'll show you the weight difference between a hollow frame and a solid frame, and it's really not a whole lot, but I'll go ahead and this is my custom to make a frame that has about a 6mm wall. I'll demonstrate how to do this on this down tube. I want to first of all make that normal, and I'm going to do an offset entities of 6mm from this edge to here, and from this edge inside. I'll zoom out and I will draw a couple lines here to terminate the cavity. I like to kind of keep it back away from this point, which could be a stress concentration, so I'll just make a line like so, and another one, probably right about here. Do some trim work. Actually, I could use a fillet because I'm going to end up using a fillet anyway. But so I'll use my sketch fillet. Choose a fillet of about 1 centimeter. Now I'm going to create what I call a bridge. Right in the center here. Looking for my midpoint. There it is. So I'm going to do a double offset of 3mm. Do a little bit of trim work. Now that I have my sketch, I can create my cut. So this will actually be a extrude cut, and I am going to use that plane that I created way back in the day, probably the very first plane that I created, to stop that cut. So it'll be up to this plane right here, which is 6mm from the outside edge. And there it is. Turn these edges on so it's a little more visible. Oops, wrong thing. How about that one? There we go. There's our cavities. I'm going to create my inside fillets. My outside fillet is 18mm. So if I want a 6mm wall thickness, that means the inside fillet should be 12mm. Select this edge and this edge, and it's not going to be a variable, it's going to be a consistent fillet. I want that to be 1.2 centimeters. And that's what that looks like. I want to talk a little bit about these bridges. This bridge greatly increases the torsional rigidity of this tube. It's almost like cutting the tube in half. Imagine twisting this tube with or without the bridge. The bridge makes a big difference. I will do the same process for the top tube. I'm going to do that off screen. No need to go through that again, and I'll show you how that turns out. The top tube is a little more complicated, so I think I will show you some of the tricks that I use to get this. The complication comes in because it's tapered. So you could put a variable fillet in, but I don't really think it's worth it. I do it sort of by trial and error. So I'm going to select my edge here, and I'm just going to keep playing with numbers. Okay, so that is not going to work. It's too big, so I'm going to bump that down to about 1.2, see if that helps. Still too big. Let's go the other direction. Let's go 0.6, which I know will work, and then we'll work up from there. Okay, so what I'm trying to do is to get this gap to close as much as possible. I'll just do a edit feature. And let me see, the 0.7, it will work. 7 millimeters. See what that looks like. That's not bad. I think I can probably do better. Edit that feature one more time. Let's try 0.8, see what happens. I think it's going to blow up on me, but nope, it didn't. Actually, 0.8 looks great. I'm going to stick with 0.8. As promised earlier, I'm going to show you what difference it makes to have the hollow cavities. They do reduce some weight. They also allow you to put the internal cable routing in a little bit easier. You wouldn't have to have quite the wall thickness. On a tandem that I made once, I made the wall thickness significantly more, like it was 12 millimeters, doubled the wall. But let me show you the weight difference, which is pretty easy to do in SolidWorks. So I am going to, right now, the mass property, it is 409, well, how about 410 grams? And let's shut this, and then I'm going to suppress these features, and I'm going to weigh it one more time, and this time the mass properties are well, 700 or 651 grams. Of course, we're only talking about half of the frame, so the overall impact on the frame would be 480 grams, or if you're crippled by this archaic imperial system like I am, that's 17 ounces. So, a soda bottle difference in weight. Does that really make a difference? Well, I don't know. That's up to you. This concludes a series of videos on design. In future videos, we're going to get into the fun stuff, making sawdust and gluing things together. Thanks so much for watching. Please subscribe and like this video.